let's look at this application. Here we see that the lights coming into the parallel of these two parallel panes of glasses. The a fraction p of the incoming light will be reflected, and the remaining light will be transmitted. So with that, we assume that the amount going in is 1. So assume 1. Now, what amount is transmit to the goes through the glass, because p amount reflected, so 1 minus p will be transmitted, right? So let's note down those numbers here on the graph. So 1 is the total amount, 1 minus p travels through, and p will be reflected. Now, of course, for this portion, here the amount of light going into the second panel, it's 1 minus p, and we do know only 1 minus p of those will be going through. So which means 1 minus p square, right? So this one is 1 minus p square. And here this is p of the 1 minus p will be reflected. So 1 minus p times p will be this dotted line amount. And again, this is also reflected from the previous reflection. So it's 1 minus p times p, and p of those. So p times that amount, which means p squared. So 1 minus p times p squared. When it travels through the second panel, only 1 minus p of those, right? So times previous one, you get 1 minus p squared p squared. Now, if you do this analysis a couple times, and you will soon see a pattern. So the next one will be 1 minus p squared times p to the power 4. And if this is reflected again and reflected back and travel through the second panel, this will be 1 minus p squared p to the power 6. So we want to find ultimately what fraction of the incoming light is transmitted by the window. So put it in another way, we want to add all of those that's transmitted by the which means we want to add all these together. So 1 minus p squared plus 1 minus p squared times p squared plus 1 minus p squared times p to the power 4th plus, and so on and so forth. Now, because of this, in the context of this question, p is certainly less than 1, right? So therefore, this is a geometric series. Usually, I like to factor out the common factor so that I'm left with 1 as the first term, p squared as the second term, p to the 4th, and so on and so forth. And then we can identify the common ratio of this geometric series. The common ratio is p squared. Therefore, I use the formula 1 over 1 minus the ratio, which is p squared. And at the end, let's simplify that. 1 minus p squared. The bottom is 1 over 1 minus p squared can be factored as 1 minus p quantity times 1 plus p quantity. And one of the 1 minus p is cancelled, so we are left with 1 minus p over 1 plus p. So this concludes this problem number 6.